Welcome back to the Physics Bible. In this video we're going to look at CP5, which is all about light and the electromagnetic spectrum. Let's get started. This one's a little bit shorter than the other topics. Oh, almost forgot. You must remember, you can do this. Okay, so first question, let's dive straight in. And the question is, list the order of the electromagnetic spectrum starting with the biggest wavelength. Now remember, wavelength is the distance from one peak to the next, or from one trough to the next. So the biggest wavelength is going to be this one, and number 7 is going to be the smallest wavelength, waves that look a lot more like that. Now I'm interested in the distance here, nothing to do with the height of it. For some reason I've actually made the amplitude of that one smaller as well, but we're not interested in the amplitude, it's purely the distance from there to there and from there to there, and we can see that one's a lot shorter. The biggest wavelength, well, how about I give you the first letter, see if you can get that one, and then fill in all of the rest. We'll go through that in a couple of seconds. So the order is radio waves, microwaves, infrared, and right in the middle is visible light, the thing that we use our eyes to see. The next three have a much smaller wavelength than visible light, and these ones are actually the ones that are a high energy, and the ones down here we tend to think of these as a lower energy. They're a lot less dangerous than the ones that are up here. Did you get them? Well, after visible light we have ultraviolet, then X-rays, and finally gamma rays. Which of these has the lowest frequency? So that's a question asking, do you know the relationship between wavelength and frequency? Well, think about this. If that wave travelled across this page, and it was a lot longer so we could count lots of wavelengths, and then this one moved across the page at the same speed, and that's the important bit, if they're moving at the same speed, which one would have more full wavelengths passing past the pen per second? Hopefully you said this one. Because the wavelength is smaller, the waves are more bunched up, and so that if they were to go past the pen at a set speed, I might get, well, let's try it, might get 1, 2, 3 or 4 waves if it moved at that speed, so maybe 4 Hertz. Whilst if that did the same thing, well, I might only get 1 full wavelength go past the pen in 1 second. So that has a lower frequency. So the bigger the wavelength, the lower the frequency. So it's like the question is almost saying, which one has the biggest wavelength, if it says which one has the lowest frequency. So the answer is radio waves. Next, name 2 things all of these EM waves have in common. 2 things that every single one of these has in common. Have a go yourself. If you used your revision guide, you might have seen that there's quite a few answers to this, and it's been a past paper question before. you could go the direction of thinking about, well, let's just treat them as waves. I mean, all of these have got to have in common what all waves have in common, because they are all waves. So we could say they all transfer energy. We could say they all are caused by oscillations. So there has to be some sort of vibration that causes the wave to be created. We can also have that they all move at the same speed, because all of these are going to move at the speed of light. And what we've got to make sure what we avoid, and what some candidates might put down, is that they all have the same wavelength or frequency. And quite clearly we've just been talking about how every single one of them has a different wavelength. These ones down here have a small wavelength, and these ones up here have a larger wavelength. If it was me and I was being asked about what do EM waves have in common, I would go for the fact that they all transfer energy and that they all travel at the same speed. Nice and safe. Next, there's 3 parts of the electromagnetic spectrum that are used for communication. So which 3 of these are used for communication? The first one's probably obvious, and that's radio waves. Radio waves transmit information to your radio, funnily enough. So that's proof that they can be used for communication. The other 2, it's all the lowest wavelengths. So radio waves, microwaves, infrared, and I guess you could have visible light as well. Visible light can easily be used for communication because you can see the light and therefore you can communicate with it. In fact, we use light to communicate to ships from lighthouses. What do the other ones do? Well, microwaves are responsible for information being sent to your sky dish, for example, or closer to home, microwaves are what we use for mobile phone signals and also for Wi-Fi signals. Infrared can be used to transmit a code. So for example, a remote control will communicate with your TV by flashes or pulses of infrared light, which the TV picks up, and it knows which button you've pressed. Next, describe how 2 different parts of the electromagnetic spectrum are used for cooking. So which 2 parts do you think these are? Well, one of them's pretty obvious, because the infrared part is heat. Heat or thermal energy can be transferred from one place to another by an infrared wave. Now, when you pick up radio waves on your radio, it doesn't make your radio hot. If you were to pick up microwaves, it wouldn't make your phone hot. The only heat coming from that, or even the radio, would be from the electricity or the battery. It's not actually being created by these 2. But infrared is heat, and so if we're looking at what can be used for cooking, then infrared would definitely be one of them. If we look at the others, visible light, can we use that for cooking? Only to see it, but it won't cook your food. Ultraviolet, again, no. X-rays, no. Gamma rays, no. None of these will cook food. Now, I've probably overcomplicated a bit, and to be honest, I tried to lead you away from the answer a little bit, so that was sneaky. But the answer is microwaves. And hopefully we'll have heard of a microwave, the actual object in the kitchen, before. What a microwave in the kitchen does is it produces microwaves which match the size of the water molecules in your food. And so the energy in the microwaves makes the water molecules vibrate, and when it vibrates, that actually heats up the food. So infrared directly heats up food because energy is being passed to it. However, microwaves kind of indirectly heat it up, because what they're doing is they're heating up anything which contains water, and therefore the food gets hot. If you just put a plate in the microwave, put it on for a few seconds, and then take the plate out, if your microwave is new or working properly, the plate shouldn't be hot at all, because the plate doesn't have water in it. Describe a use for UV, X-rays and gamma rays. So we want one use for each of these. Write them down yourself and then check in a couple of seconds. Okay, so a use for ultraviolet light, we can use it to check forgery of banknotes. You may get this when you pay for something with a note. You may see the cashier hold it under an ultraviolet light, because there'll be secret markings on the notes which are supposed to just be on notes that are real. So it can be used for that. It can also be used to sterilize water, and that's because UV has quite a high energy, and it can kill bacteria, so strong ultraviolet light can actually be used to sterilize things. For X-rays, a medical X-ray, hopefully you've not had to have one of those. If you have, it may be because you've broken a bone, and so a use for X-rays would be to be able to see broken bones, or to see bones. And that's because X-rays have so much energy that they can pass through skin and muscle, but they can't pass through bone. And so when the X-rays are detected on the other side, it forms an image where the bone should have been. Obviously the X-rays don't reach the other side of your body, so it creates like a shadow, and we can see whether there's breaks in the bone if there's little lines in the shadow. Finally, gamma. Now, gamma is such a high energy wave that if used incorrectly, it can be very dangerous. Similarly, for X-rays, you're only supposed to have 7 per year, or it was last time I checked, because being exposed to X-rays exposes you to high energy radiation, and we want to keep that to a safe number. If you've had more than 7, don't worry, it doesn't mean that there's going to be anything wrong with you. It just means that the doctors decided that it was more important to actually see the X-ray than it is to just not give you it, because of the very, very, very small chance of some of your cells being mutated by the X-rays. If you're being treated by gamma rays, unfortunately it's probably as a treatment of cancer, because gamma have such a high energy that they can kill living cells. So what they do in gamma knife treatment, for example, is they target the tumour, maybe it's in your brain, it could be there, and they fire gamma rays from lots of different angles. And what that means is lots of areas are just exposed to a little bit of gamma, but the intersecting point, that there, is actually having lots of gamma pass through it. So that area there would probably be exposed to so much gamma that it would kill the cells, and therefore it would kill the tumour. This obviously is not a 100% foolproof method, but if you're having the surgery, it means the doctors have decided that it's better to take the risk of firing gamma rays through the brain than it is to operate and actually cut you open or to leave it. Being a doctor is all about making decisions. Often there's risks with any decision that's being made, and they have to think, well, what's the one that's most likely to give you the good outcome that you want? Okay, next. Which electromagnetic wave is the most dangerous and why? Hopefully we've now picked up that gamma is the most dangerous because it has the most energy. We could also say it's got the highest frequency. Because it's got the highest frequency, that means that it has the most energy. We just need to list some dangers of the following. So, dangers of infrared. It transfers thermal energy, and so anything that transfers thermal energy can cause burns. Ultraviolet can damage skin cells. It can even cause mutations to skin cells. If left unchecked, high exposure to ultraviolet light could cause skin cancer. It could cause your cells to mutate and replicate uncontrolled. X-rays and gamma rays, a danger of these? Well, these are such high energy waves that they might not just cause mutations, but they could actually kill the cells completely. In very extreme cases, this could mean that entire organs could shut down because so many of the cells are being killed by the gamma and X-rays that are able to travel through your body. As they travel through your body, some of them are going to get absorbed by your internal organs. So they can cause mutations which leads to cancer, or they can even kill. They can even kill cells. So there's a danger that gamma or X-rays can kill cells, and we can say that's dangerous, but actually in medical terms, if we use gamma to treat a tumour, we're using gamma to kill cells, but it's for a good reason. Why do people have X-rays if they are dangerous? I was talking about this before. They're not dangerous, so going for an X-ray is not considered dangerous. You've probably got more chance of being killed in a car crash on the way home than you have of getting cancer from a single X-ray. So why do people have them? The benefit of having the X-ray outweighs the risk. In other words, the risk is so small, but the benefit you get from having an X-ray and being able to see what's wrong with the bones, it's worth that tiny risk. Next, give one similarity and one difference between visible light and X-rays. Okay, a similarity, we could say that they can both travel through a vacuum. Similarity, you could say they're both EM waves, so they're both oscillations in the electromagnetic field. A similarity again is they both transfer energy. There'll be more. A difference, Well, the difference between anything in the electromagnetic spectrum is the fact that they all have different wavelengths or different frequencies. So I would state that, but to make sure I get the marks, I would say which one has the highest wavelength or frequency. So I'm going to say that for a difference, X-rays have a higher frequency. Okay, that's the end of the electromagnetic part. Next video we'll be looking at CP6, which is the radioactivity section, and this is the last section in the paper 5 part of the combined physics GCSE. So hope you found this helpful, and I'll see you in the next video.